Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deep programming language series. And today we're going to be talking about pointers. So if you're coming from a C or a C++ background, pointers are going to be very familiar. They operate in basically the same way. A pointer is a tool to store an address, and typically it's a tool involved with memory allocation at runtime or sharing of data. Those are sort of the use cases of pointers. So I want to go ahead and just give you the brief introduction to pointers in this lesson, and then we'll go ahead and continue talking about pointers where relevant, things like function pointers or passing pointers into a function. And that'll help you better also understand how pointers sort of work in D or some of the data structures like the slice or the dynamic array that we've been using in this series, how there's a pointer to some data somewhere in those structures. But with that said, let's go ahead and start with the fundamentals by first looking at the D documentation. And I'm going to go ahead and just open up the documentation. Let's go to the language page here. I'm going to go to types, and then we'll find here the derived data types. You'll see the category for pointers. So let's go ahead and click on that and zoom in a little bit here. And basically, what is a pointer? Well, it's a pointer which has a reference or an address to another object. Okay, it doesn't matter if that object is a class, a struct, or just some basic variable, which would be, again, a value type. It's just holding an address so that you can access that element. So I've got a little example here where we can see that we are initializing the value p, checking if it has been initialized here with some memory here, and then asserting that the value here where we've created this one single integer, initializing to 5, has the value 5. Now, again, if you haven't seen pointers, that's what this video is for. So I've got to explain some of the syntax like the star here and what exactly is going on with the star also by the data type. So let's go ahead and start with that. And I'm going to go ahead and remove this example. You can go ahead and run this if you want here. But let's just go ahead and build it from scratch so again we can understand what a pointer is. So again, a pointer is a data type for storing an address. And it's going to store the particular address of a specific data type. So int star is a pointer to an integer. And usually we prefix these with p here, so I'm just going to name this p here. Okay, so that's the idea here. So it's its own storage, and we're going to actually just draw this out here in its own box. And let's go ahead and label this here. This is going to be int star p. And then, well, what's inside of this box? Well, it's going to be an address. Okay, so let's just go ahead and label it here. A pointer stores an address. Okay, so that means some other variable, something else that's an integer. Okay, because that's the type. And let's go ahead and qualify our statement. So it stores an address of a specific type. Now, there are exceptions to that where you can have a void star, which can point to anything. And I'll just go ahead and put that in parentheses as well, exception. And I'll go ahead and say void star can store any type. Okay, just so you have an idea here of what is going on. So let's just go ahead and create another variable here. And I'm just going to create an integer x here. Let's assign it to some number here, 77. And if a pointer holds an address, well, that means we need the address of x here. And we've learned about the ampersand operator. If you prefer, you can wrap it in parentheses. If you prefer to think of this as a function, most of the time folks will just abbreviate it as such. Okay, so let's go ahead and just compile this just to make sure that it's working. Again, no syntax errors here. It's working fine. Now, again, with our pointer here, it's storing the address of x. So let's go ahead and add that into our diagram here. So I've got int x down here, and it equals 77. So let's just go ahead and put 77 inside of its box. And this has an address associated with it. Okay, so let's try to decipher a little bit what's going on here. So let's go ahead and write out here x, the value. We'll go ahead and write out p. And then let's go ahead and write out the address of x. And then let's go ahead and write out the address of p here. And I'm going to go ahead and just put a right line here just to make things a little bit cleaner here. But let's go ahead and see what this program now generates for us. Okay. And let me just space this so everything fits nicely on the screen. And let's go ahead and run here, our main here. Okay. So just going through this one by one here, we see that the first thing that's written out is x is 77. Okay, and we notice that that's in our box here. That works fine. And then we write out P here. And you'll notice that we get this gigantic looking number here, and this is actually in hexadecimal. And this is the address that is stored in P here. So I'm going to try to type this out or write this out. Just, 7FF C4 1, and I'll have to go to the next line here. BB 3 CC 0. And that's what's, again, stored in P here. Okay, that's what we've written out here. Now let's go ahead and just write out the address of X here. So if I go ahead and label this, and usually we put OX just to indicate that it's hexadecimal, but that is in fact 77 FF C41 BB C C0. And you'll notice that that's the exact same thing that's stored in X here. Okay, so what this is storing here is the address of X here. And notice how I'm drawing this arrow over to the address here, because that's what's stored inside of P here. Okay, so again, I'm being very careful there. It's not storing 77, but it's just storing the address of where this value X lives. Okay, that's the idea. And then the address of P, well, this pointer has its own address here. So let's just go ahead and write that out so that we're being complete. So 0x7 FF C41 BB CC8. And you'll notice that it's offset by 8 bytes. That's what we're printing out with these addresses, because pointers on a 64-bit system, so 64 bits is 8 bytes of information. So that's the size of this data type here, int star. And again, being careful to include int star. You can put the asterisks, or the stars that's sometimes called here, with the variable. It's sort of a stylistic thing. It means the same thing, so you're fine either way here. Okay, so that's the basic idea here with our pointer here. So it's kind of neat, but what does this give us? Well, we're able to, since we're storing the address of X here, we're able to indirectly access this value here, 77. Okay, so let's go ahead and see what that looks like if I want to store the address. And this is what's going to be known as dereferencing. Okay, so I'm going to go ahead and write out here. I'm going to say dereference P. And how do I do that? Well, I use the star beforehand. And again, the star or the asterisk here, it's, when we used it in this context, it was part of the declaration. We said, here's the data type of what P is. But here we're saying, since we're actually just using P, which is our pointer to some integer here, then we're dereferencing it and saying, hey, access the value. So what's the actual value at this address? Well, it should give us 77. Okay, so let's go ahead and make sure we save this. We'll go ahead and run it. And we can see when we dereference P, we in fact get that value, 77. So what's kind of neat here with this dereferencing is it gives us a sort of layer of indirection. So dereference, and we'll go ahead and just state what this is retrieve the value at the address. Okay, we store. Okay, and I'm just going to put in parentheses here this concept of indirection. Okay, because again, we're just storing with pointers the address here, but not the actual value. Okay, and again, why do we want to do this? So what's the point of pointers here? Okay, so let me sort of create a little category here. The point of pointers. So for storing addresses, that's what their job is. That's all they do. The point is for sharing in some cases. And I'll go ahead and show you what sharing looks like. Well, since I'm just storing the address, what if I created another pointer here, P2, and that's also storing the value X here. Okay, so let me go ahead and just split our screen here so we can see what's going on when I actually run this. So now what I want to do here is let's go ahead and dereference P2, our second pointer here. Okay, and let's go ahead and just make this just a little smaller. I'll try to get everything on the screen. There we go. And if I go ahead and run this example with our main, we'll see that when we dereference P2, well, we in fact get 77. So what I've done here is I've just created another place in memory here, int star P, and it looks exactly the same almost here. It's got its own address. So this is going to be at, C 16 here. So whatever that value is incremented by 8 here, but it's going to store the same address here, 7ff cc0. Okay, same thing in this box. So it's indirectly pointing over here. Okay, that same address. So that's kind of cool. That's actually a very powerful idea. I'll get rid of this other box so we're not too cluttered. But this idea that I can have 2 pointers to the same value. So when I do one update here to the value x, indirectly we're updating, everything else that's sharing that data. So in a way, this could be super efficient if we're passing around information in functions, for instance, or otherwise if if we need to share information among data structures and so on. So that's a key use case of pointers. The other is for linked data structures. Again, you can create things like linked lists. So for instance, maybe I'll show this in a later video, but this idea that, well, if I have one pointer, I can sort of point to another address and then, have another box that points to another address and sort of create these linked or tree data structures. That's how they're implemented behind the scenes. The fourth thing, which kind of goes along with this, is for memory allocation. Okay. And specifically at runtime. Okay. Now I'll show you memory allocation or the malloc function in a separate video, but we need to be able to ask for memory from our operating system. So for example, and let me just go ahead and make this a little bit larger just so we can see here. But while my program is running and I have my source code over here, I might want to call a function that allocates memory, whether explicitly, something like malloc, or when we're using new, behind the scenes, it's essentially either of these functions are asking our operating system, on our computer here. So let's draw a little computer in our operating system that's running. Here's our mouse and this is our source code. But basically the operating system is saying, hey, I'll give you, this chunk of memory here when you call malloc or when you call new here. And you're pointing to the first address in each of these chunks of memory and then however much memory that you ask for. Okay, so when we're using new or malloc, that's essentially what's happening. Now in D, we don't often have to think about this as much. So for instance, when we've been just using things like, when we get into classes or structures, or when we're just using some sort of, list of numbers here and just appending to it or just using it here, that kind of memory allocation might be happening behind the scenes. Okay, but hopefully that makes a little bit clear what the point of our pointers are. Now let's go ahead and play around with this example a little bit. So I think we've got the motivation. This is kind of where we're going to go in the series in a little bit here, just to talk about a few of these things so you'll have an idea. But let's go ahead and just play around with some more examples here. Okay, so let me go ahead and clear this out here. And the other things that I want to show you is what happens if a pointer doesn't store anything. So let's just create another pointer here. I'll call it P3. And let's just go ahead and write out P3 here. Let's see what it stores here. So if I go ahead and run this, you'll see that it just has this value null. And null is just sort of a special means, in practice, what it is just a value 0, but what it's storing is nothing. It's not pointing to any address. So we can check, for instance, if P3, and then we could say, is it null? Okay, so if it is null, and I should say is null here, let's just go ahead and write out here. This means that if this doesn't print out, or sorry, let me make this clearer here. Because it's just the value 0, this isn't going to evaluate. So we could do this a couple of ways here. We could say if P3 is null, then we'll see that, well, it is null here. Or sometimes folks will just say, equals null. And that does the same thing here. So let me go ahead and just, run this here. There we are. So it is null. So however we want to write it out, I like in D, the sort of D way is to say if P3 is null here. That's a little bit clear. If you're coming from more of a C background, again, you might just do this or the exclamation here to say, if it is in fact null, that'll get you the same result. Okay. So you might use that as a check, because what happens if you try to access something that is null here, like let's just try to dereference a null value here. And we'll go ahead and run it. Well, then we'll get what's known as a segmentation fault, because this is storing the value 0. And if I'm trying to address the or dereference the value at 0, that gives us a segmentation fault. Okay, and I'll talk about that a little bit more in some of our pitfalls when working with pointers. Okay, so let me just kind of keep that in mind here. Let's just go ahead and annotate that and say illegal to dereference a null pointer. Okay, so usually we try to check for null pointers, okay, when we're using them. All right, so that's just a few notes on null pointers here. And let me go ahead and just space this out, and then you can go ahead and read this a little bit easier. All right. Now, the last things that I want to go ahead and tell you about pointers is let's just try to use it with some other stuff that we've learned in D here, like auto. And these are the types of experiments that you could try to do here. P4 equals the address of X. So, my question is, will we infer that P4 is in fact a pointer type? We're storing an address here. So let's see how smart the D compiler is. And let's go ahead and run this here. It doesn't crash or anything. So how can we check? Well, let's not forget about type ID. We can use that here. And that'll give us the type here. And we should see that it's able to infer that this is, well, X is an integer. So this must be a pointer to an integer. Okay, so let's see what the last thing is that it prints out. And in fact, it does print out int star here. That is the type of P4. So we can use auto. We don't put, it's going to give us an error or something if I do auto star here, right? It's going to say, it's able to infer that this is a pointer type. Okay, now the last thing that I want to do here is just give a little bit of a teaser to some of the things that we're going to talk about later, because when we're storing addresses, we can store addresses of variables like I've shown, but also functions. So the one function that we have in this program here is our main function here. Okay, that's a function. So let's go ahead and try this and see what happens. And well, now we can see what the address of is main, or really any function that we actually type out. So this could be really powerful when we talk about pointers being able to point to data, and maybe that data being able to change what we're pointing to. So maybe if we're pointing to different functions, and if we dereference, or in other words, just call those functions, we can change the behavior of our program. So by changing where our pointers go. And that's really one of the points of pointers and the power of them. Okay, so I'll actually add that maybe as bullet number 5 here. These categories aren't necessarily, there's some overlap here. So I'll go ahead and say for storing addresses, it's kind of the same idea of, function pointers. And actually, let me just abbreviate this PTR, because that's the abbreviation you'll sometimes see with pointer in either the documentation, just so you're not confused where that's coming from. So function pointers. So that's the basic idea of pointers. They're very powerful. If you're coming again from a C or C++ background, a lot of this should be familiar. In fact, probably the only thing new for you is maybe type ID if you haven't been following along there, or that you can do. Let me actually show you the is null again, because I like that syntax a little bit better. It just reads a little bit nicer. P3 is null. So I like that there. Otherwise, again, as I mentioned, this should be relatively familiar. We'll get into later, again, mallocing and doing some manual memory allocation, so you don't have to use D's garbage collector. I'll talk about what D's garbage collector is if you're not aware of that as well. But with that said, folks, I hope that was a useful introduction to pointers here, and that you kind of understand just what the exact tool is. D is a systems programming language, so it's really nice that we're able to use pointers. Now, that being said, you can go through and use the D programming language without really having to think in pointers if you want. In fact, for a lot of the smaller projects that I do, I never really even think about pointers. I'm using the built-in data structures to achieve my work, and that's really all there is to it. So it's nice to be able to have different levels where you can think in this programming language. All right, folks, so I hope you enjoyed that. If you have any questions, feel free to engage in the discussion. And with that said, thank you as always for your time and attention. Make sure you subscribe so you don't miss any future lessons coming in this series, and we'll see you in the next one.